Today, we're diving into what is, quite possibly, the most important scientific book ever written. And I'm not exaggerating. This is a book that didn't just give us a few answers, it handed us a completely new universe.
I mean, it's a massive question, right? One we've been asking ourselves forever. Is there some logic to it all? A set of rules that governs everything from the planets spinning in the heavens to something as simple as an apple falling from a tree?
For the longest time, nobody knew. It was a total mystery. And then, in 1687, this book shows up. It's called Philosophiæ Naturalis Principia Mathematica. A bit of a mouthful. It means the mathematical principles of natural philosophy. And inside, Sir Isaac Newton laid out the rules of the game. Okay, so to really get just how big of a deal the Principia was, you gotta transport yourself back in time. We're talking about a world where the night sky was this huge, beautiful puzzle. People had been watching it for centuries, they had tons of data, but no one had the big picture. See, they'd figured out the how. Guys like Johannes Kepler, brilliant astronomers, they knew that planets moved in these oval shapes, ellipses, not perfect circles. So the geometry, the math of how it worked, that was pretty solid. But the big nagging question was why? What was making them do that? What invisible string was pulling them along?
Well, the answer was going to come from one of the most brilliant and honestly complicated minds in all of history. A guy who was kind of a recluse, not super eager to share his work, but whose ideas were about to change, well, everything. And that man was, of course, Sir Isaac Newton. Yeah, we all know the name, but the story of the man himself and what made him tick, now that's where things get really interesting.
You know, if you looked at his early life, you wouldn't necessarily peg him as a world-changing genius. But then he gets into Cambridge. And in 1666, something happens. The plague hits. He's forced to go home, and that period becomes his annus mirabilis, his year of wonders. It's where the seeds for all his biggest ideas really started to grow. And here's a fun little tidbit. His biographer says that as a kid, Newton wasn't a great student at all. Kind of checked out. But then he gets into a fight with a school bully, and something just clicks. It's like that fight lit a fire in him, this competitive streak that would eventually push him to take on the biggest scientific questions of his time. So let's go back to that year of wonders. The Great Plague shuts down Cambridge, and Newton heads back here to his childhood home in Woolsthorpe. And in that quiet, with no distractions, his mind just exploded. This is where he laid the groundwork for calculus, for his theories on light and optics, and the big one, universal gravitation. But here's the thing. He basically sat on these incredible ideas for years. They were just his own private notes, his obsession. It was going to take a little push from a friend and a serious rivalry with an enemy to get him to finally publish. So flash forward to 1684. The famous astronomer Edmund Halley, yeah, the comet guy, pays Newton a visit, and he has this one burning question. A lot of scientists suspected that whatever force was holding the planets in orbit got weaker the farther you got from the sun, following what they called an inverse square law. Halley's question was simple. If that's true, what path would a planet actually trace through space? And Newton, without even blinking, just says, an ellipse. He'd already figured it out years before. Now, he couldn't find the notes right then and there, but he promised to send the proof to Halley. And that conversation just set him off. See, his big rival, Robert Hooke, had been claiming he had the same idea, but Hooke didn't have the math to back it up. Newton was now on a mission to show everyone who the real master was. So with Halley cheering him on, and even paying for the printing, Newton basically locks himself away for 2 years in this insane burst of creative energy. And what comes out of it is the Principia, the book that was literally the master key to understanding the universe. And at the core of it are his 3 laws of motion. They're so simple, but so powerful. Number 1, inertia. Basically, stuff keeps doing what it's doing unless you mess with it. Number 2, force equals mass times acceleration, F equals ma. And number 3, for every action, there's an equal and opposite reaction. I mean, these 3 little rules, they explain pretty much all the motion we see in our daily lives. But then he makes this incredible leap. He says this force, this gravity, it's not just for planets, it's universal. Every single particle in the universe is pulling on every other particle. A speck of dust, a planet, a star, you, me, everything is connected by this force. Now, this is where that famous apple story comes in. And look, whether an apple actually hit him on the head doesn't really matter. The story is perfect because it captures his light bulb moment.
He realized that the force pulling that apple down to the ground was the very same force that was keeping the moon locked in its orbit around the Earth. He explained this with a really cool thought experiment. Imagine you're on a super tall mountain with a cannon. You fire a cannonball and gravity pulls it down. Okay, you fire it faster, it goes further before it hits the ground. But what if you could fire it so fast that as it falls towards the Earth is curving away from it at the exact same rate? It would just keep falling forever. And that, my friends, is what an orbit is. The moon, he realized, is just a giant cannonball constantly falling around the Earth. And that was the revolution. Before Newton, people thought the heavens had their own special rules and Earth had ours. Newton showed that was wrong. The rules are the same everywhere. The physics of a falling apple is the physics of a planet. Suddenly, the universe wasn't some mysterious divided place. It was one single system, all running on the same set of understandable laws. I mean, it is truly impossible to overstate how much this book changed everything. It wasn't just about science. It fundamentally changed how we, as a species, saw ourselves and our place in the universe. Think about it, the Principia basically invented the field we now call classical mechanics. It showed the universe wasn't chaotic or run by random whims. No, it was rational, it was understandable, it followed mathematical rules. That idea became the foundation of physics for more than 200 years and was a huge catalyst for the whole Age of Enlightenment. And all of that came from this one single book. Sure, it's a tough read, it's dense, but what's inside is basically a blueprint for how the whole universe works, all written in the pure language of math. And yet, after all of that, after literally rewriting the rules of the universe, Newton was still so humble. Towards the end of his life, he said this, suggesting that everything he'd figured out was just playing around on the edge of a vast, undiscovered ocean of truth. And maybe that's the real legacy of the Principia. It wasn't just about the answers it gave us. It was that it gave us the tools and the confidence to keep asking even bigger questions, which really makes you wonder, doesn't it? What great oceans of truth are still out there just waiting for us to discover?